Deploy Azure infrastructure seamlessly using Terraform with Azure Verified Modules and Github Actions. In this demo, you'll learn to create an automation pipeline that sets up a resource group and virtual network in Azure. By the end, you'll have a fully automated system with a GitHub repository, Azure Verified Modules, and live Azure resources deployed through the pipeline. Let's kick things off by setting up a GitHub organization to organize our project. First, log into GitHub or create a new account if you don't have one. Navigate to your account settings and click Your Organizations, then select New Organization. Choose the free plan and enter a name of your choice. It is also required to add a contact email and specify if you want the organization to be personal or connected to a business or institution. Lastly, you will have to verify your account and accept the terms and conditions after reading them. Once done, your organization is ready to house a repository for this project. Go to the Organizations page, click New Repository and name it Azure Deployments. Make it public or private depending on your preference. This repository will host your Terraform code and GitHub Actions workflow. To authenticate your GitHub workflow with Azure, we need to create a managed identity in the Azure portal. Navigate to Resources in your subscription and click Create. Search for Managed Identity in the search bar. Click Create under User-Assigned Managed Identity. Choose an existing resource group or create a new one. Enter a name for the managed identity resource such as Terraform GitHub Identity, and create. After creation, go to the Managed Identity resource. Click Federated Credentials. Add a credential that links to your GitHub repository and fill in your organization and repository name. Also, link the main branch to this identity. This means that only the main branch can use this identity as of now. After assigning a name to the federated credential, click Add. In the Identities menu, click Azure Role Assignments. Click Add Role Assignment. Choose Subscription as your scope, with a contributor role, so that the managed identity is allowed to create Azure resources. When you are done, save and move to the Identity Overview. From here, we want to copy Client ID and Subscription ID. We also need to copy the tenant ID from tenant properties. We will use these values in the next stage. Go to Repository Settings and add the variables as repository secrets to avoid having secrets in your code. Your repository secrets should look like this when finished. Navigate back to the Code tab. To manage Azure resources using Terraform and pipelines, you need to store the state file remotely. For this scenario, we will store it in Azure. In the portal, create a storage account on your subscription. Make sure you are assigning a globally unique name. In a production scenario, you would want to disable public network access and assign a private endpoint to connect to the storage account. Navigate to the resource after deployment and create a container called tfstate. You also need to configure access for the managed identity. Go to Access Control, IAM, and click Add Role Assignment. Select Role Storage Blob Data Contributor. Assign access to the managed identity created previously. In your GitHub repository, create a new file and start by configuring the Terraform providers in a file called providers.tf. Add the provider configuration and make sure to have the correct storage account and resource group name, then commit changes. Create a new file called variables.tf. Your variables file defines all the configurable parameters for our infrastructure. Notice how each variable has a description, type, and default value. In this example, we will be using Azure Verified Modules to define a resource group and virtual network in our file called main.tf. Find the modules from aka.ms/avm. Make sure to include the required inputs. All Azure Verified Modules come with examples to be easily used. Notice by looking at the source how it points to the remote module. Also, take note of the variables being used that we defined in the previous file. Normally, you would not want to commit directly to the main branch, but since this is a new repository with initial configuration, it can be bypassed for now. Lastly, create a file named terraform.tf vars. The file is optional in this case, since we have default values in the file called variables.tf. Finally, set up a GitHub Actions workflow for automation. Navigate to the Actions tab and create a new workflow. Use a pre-built Terraform template or write a custom YAML file to define steps like initializing Terraform, planning changes, and applying them. Notice how the environment variables point to the secrets created earlier. Once saved, your pipeline will be ready to deploy resources automatically and will be triggered when pushing to the main branch. Congratulations, you've set up a complete CI/CD pipeline to deploy Azure infrastructure using Terraform and GitHub Actions. Check out your deployed resources in the Azure portal. Don't forget to customize and expand your setup to meet your specific requirements. To continue working on a repository like this, make sure to clone the repository locally or use code spaces. Make Git branches with pull requests and use tools like Visual Studio Code.